Alright class, we are going to start a new topic, that is vectors. In last class we had discussed the past paper question of the topic transformation. I hope that all of you are clear regarding the regarding the topic of transformation, right? So in today's class, a new topic, vectors. So first thing, what are vectors? Basically in physics we have two quantities, the one we called scalars and the one we called vectors. Scalar quantities are those quantities which only need a magnitude to represent them. Like if you talk about mass is an scalar quantity, right? So all those quantities which requires a magnitude only is called scalar quantity. For vector quantities, they require magnitude, but not magnitude only, they require a direction as well. So direction plays an important role in vectors, right? Like suppose if I say that move 5 kilometers, right? So the first thing you are going to ask, that is, should I move forward, backward, left or right? So basically this clarification will be done by the direction. Or if I say move 5 steps to the right, so you are very clear that where should you move now, right? So displacement is a vector quantity, it needs direction. Velocity is a vector quantity, right? So in example I will say that displacement, velocity, these are vector quantity. For scalar we say that mass and speed are scalar quantities. That is a basic introduction of vectors. Now the second thing is representation. How you define a vector. Now we define a vector by an arrow, right? We can define the vector by an arrow. Let's suppose I can say that is a vector of xy having a value of 5 units, right? So direction is very important in vectors. So this 5 unit represents from x to y, it has a weightage of 5 units, or you can say that xy is 5 units. Make it your habit to show this arrow in vectors. Whenever you are representing a vector, it should be marked with the arrow, because arrow plays an important part. Now in this case, in this type of writing style, it indicates that the starting point is x till the ending point is y, right? So xy represents 5 units. Similarly, if I say that a b, so how I will write this, it will be a to b. If it's b to a, b a. So that is a representation of a metric vectors by a line with an arrow on its head, right? Now let's suppose how you represent the vectors on graph, or we can say that vectors on Cartesian plane. By Cartesian it's same as your xy axis. How you represent the vectors on Cartesian plate? 1 2 3 4 5, 1 2 3 4 5. Let's suppose I make a vector, this one, right, starting with 1 1 and ending at 5 comma 5. So how you represent the vector? We will count the distance at the x-axis. So starting with the 1 till 5, that means there are 4 units. On the right and there are 4 units at y-axis. So it means it has a position of 4 and 4. If it's a b, so I will write that ab is equals to 4 and 4. That how we represent the vectors on graph. The first alphabet, it represents the value on x-axis. The second one represents the value on y-axis. So that's how we represent the vectors on graph, or you can say that on Cartesian plane. And this notation we call that column vector. That is column vector, right? So the first thing in vectors that you need to learn is how you find out the magnitude of a vector. Now in general, without the content of magnitude, in general, if I draw the right angle triangle in which its length 4 and this length is, suppose that it's 5, and my question is what is the value of x. So mostly students can answer me with the help of Pythagoras that it will be x square is equals to 5 square plus 4 square with the root sign, and remove the square sign here, right? So that's how you apply the Pythagoras theorem to find out the magnitude, and the same working formula we use that in magnitude, how to find the magnitude of a vector. In this example here, we have a and b with the coordinates 4 and 4, right? If I want to find out the magnitude of AB, the working formula is x square plus y square, and we got this formula by the help of Pythagoras. That is the same approach, same technique, right? The working formula to find out the magnitude is x square plus y square. If we talk about AB, the value on the x is 4, so it's 4 square plus value on the y is 4, that is root 32, right? So that is the answer of magnitude of AB, and the working formula is a square plus x square plus y square. That is the working formula of magnitude of a vector. So note down all the things that I have told you, starting with this point. Note down all the things. These are the basic notes of vectors, right? At first I told you that what are vectors. Vectors are those quantities which require magnitude and direction both, right? Like we have displacement, we have velocity, in which we need direction. How we represent the vector? With the help of arrow, and the important thing on the arrow is its head. Head defines the direction, right? Like I say that xy, it starts from x till y, so it defines that direction. After that, we had covered vectors on graph x and y, and we call it Cartesian plane, right? And the last, we had discussed about the magnitude of a vector. We can find the magnitude of vector by the simple working formula of x square plus y square. Now there are some type of vectors. I hope that all of you had note down till here. First, I will discuss about the equal vectors. So equal vectors are those vectors which have same magnitude and same direction. Like I say that if it's a vector A to B having a value of 5 units, and there is another vector of P to Q having a value of 5 It means that AB and PQ are equal. Both have same length, same magnitude, that is 5 units, and both have same direction. So we call these vectors are equal vectors. Note it down. After equal vectors, we have negative vectors. Now what are negative vectors? Negative vectors are those which have same magnitude but opposite direction. Opposite direction, like that is my vector AB 5 units, and that is my vector PQ 5 units. Now AB and PQ are opposite negative vectors, right? That is the concept of equal vectors and negative vectors. Equal vectors have same magnitude, same direction, but negative vectors have same magnitude but opposite direction. Simply, if I say that there is a vector xy, what is the opposite of xy? So it's very simple, it's yx, right? We are not talking about magnitude because xy or yx, they have the same magnitude, right? So it totally depends on the direction. If the direction and magnitude is same, then we have equal, and if the direction is opposite but the magnitude is same, then we have negative vectors. Alright, I hope all of you had noted down all the things. After that, we will begin this exercise. It's 7A from your book 4 7th edition. Exercise 7A, book 4 7th edition, page number 225. Question number 1. Find the magnitude of each of the following. So first part, it's 3 and 4. Before starting the question, let me tell you the working formula. To find out the magnitude of any vector, the working formula is under root x square plus y square. In order to find out the magnitude of 3 4, so it will be under root 3 square plus 4 square. 3 square is 9 and 4 square it's 16. 16 plus 9 it's 25, and the root of 25 is 5. Right? Simple, not complicated, not difficult, very simple word problem, or not a word problem, very simple question it is. Note it down in your copies. Alright, I hope that all of you had noted down. Next part, B. Column vector is 5 and minus 5 and positive 12. Find out the magnitude, and you need to do it by yourself first. So give it a try, start. I hope that all of you had done. It will be minus 5 square plus 12 square. So minus 5 square it's 25. 12 square is 144. 144. 25 plus 144, it's 169, and that is equals to 13, right? So that is the magnitude of the vector in part B. For part C, it's -7, -2. Start. Done. So it will be 7 square is 49, 2 square is 4, so 49 plus 4, it's 53, right? You can write in decimal or you can leave it as in the root form. It will be, both answers are correct. Part D, it's 0 and -6 whole 1 upon 2. You need to find out the magnitude of this vector. You need to do it by yourself, so start. Done. So it will be equals to 0 square plus -6.5 whole square. Now first thing, you need to find the square of 6.5, and that is 42.25, or it will be 0 square is 0, no need to write it down. That is equals to -6.5 square. Square and root cancel, so the final answer is 6.5. That is the answer, right? And if you have a question, sir, it was -6.5, how come it will be positive? Listen, if you find out the square of 6.5, it will be 42.25 with the positive sign and the root, right? And you find out the root, so it will be 6.5. So that's how you can solve the question. And the last part is E, vector is 8 and 0. So I can clearly see that the magnitude is 8 only because the next coordinate is 0, right? So that's how you find the magnitude of a vector, just by simply applying the working formula x square plus y square. After that, moving on to the next question, question number 2. Write down the negative of each of the following vectors. For first part, it's 12 and -7. Now what we had studied in the negative vector is that they are equal in magnitude but in opposite direction. So the negative vector of 12 and -7 is -12 and 7. So what you need to do, you need to just swap the sign, and that's it, right? After that, part B, it's -2 and 0. So -2 and 0, the negative vector, it will be 2 and 0. Similarly, start the question by yourself. Part C, it's 4, 8. Part D, it's -3, -1.2. And part E, it's 0, 3 whole 1 upon 4. Find out the negative vectors of all these questions So C part it will be -4, -8. D part it's 3 and 1.2, and E part it's 0 and -3 whole 1 upon 4. These are the negative vectors, right? I hope all of you are clear, and up till now the vectors seems very easy, right? So moving on to the next question, it's question number 3. The question says if P is equals to A and 3, Q is equals to -2 and A plus 2B, and P is equals to Q, that is given. Find the value of A and B. Now basically that condition here, what does it represent? It represents that both vectors are equal vectors, right? It represents both vectors are equal vectors. And what we had studied in equal vectors, they are equal in direction and they are equal in magnitude. So according to given condition, vector P is equals to vector Q, right? We have the column vector of P, that is A and 3. We have the column vector of Q, that is -2 and A plus 2B. Now similarly, what we did in matrices, we are going to continue with the same technique, that on both sides the order is same, right? It's A3 and -2 A plus 2B. Now you can equate the vectors easily. When you equate the vectors, so A is equals to -2, the first row complete, and 3 is equals to A plus 2B. You can easily substitute the value of A. So it will be 3 is equals to -2 plus 2B. When you shift -2 on the left side to 3 plus 2, 5 is equals to 2B, and B is equals to 5 over 2, and that is your answer, right? It looks very easy. Vectors is very easy topic, right? Yes, it is, but only at the beginning. All right. Now, I will give you one question. You need to do that first. The question says, two column vectors A and B are such that A is equals to x plus 2, 4 minus y, and B is equals to 10 minus x, y minus 5. First part, if A is equals to B, find x and y. First you need to write down the question, and then you need to do it by yourself first, and then I will start. You have 2 minutes to attempt this question. Start. It's the same question like we have attempted the last one. We need to equate the vectors because they are equal vectors according to given condition. Done? Alright. I hope that now you all have attempted the first part. It says A is equals to B. So the vector A is x plus 2, 4 minus y is equals to vector B is 10 minus x and y minus 5, right? After that you need to equate these two. So the first equation, when you equate the first row on the left and right side, it will be x plus 2 is equals to 10 minus x, right? You can solve the equation to find out the value of x. So minus x, when you shift on the left side, it will be plus x. So x plus x, it's 2x, and positive 2, when you shift on the right side, it will be 10 minus 2, that is 8. That means the value of x, it's 4, right? Similarly, you can equate the second row. So it's 4 minus y is equals to y minus 5, right? I am shifting negative y on the right side, so it will be positive y. So y plus y, it's 2y, and negative 5 on the left side, it will be positive 5. So 4 plus 5, it's 9. So y is equals to 9 over 2. That are the values of x and y, and I hope that all of you are getting the right answer. Now the second part, it says write down the negative vector of A. So first you need to do it by yourself. What is the negative vector of A? First try it by yourself, and you have 30 seconds to do this question, and then I will explain. So the vector A is x plus 2 and 4 minus y. First I will substitute the values of x and y. So x is positive 4 and y is 9 over 2, right? That is equals to 4 plus 2, 6, and 4 minus 9 upon 2 is 4.5. So 4 minus 4.5 is minus 0.5, right? So the vector A is 6 and minus 0.5. If you need to find out the negative vector, so that is equals to minus 6 and positive 0.5, right? That is the negative vector of A. Clear? In the next part, you need to find out the magnitude of A, and you need to show that it is equals to under root 145 divided by 4. And for that part, I'll give you a time of approximately 1.5 minutes. Start. Done? Alright. So it will be the magnitude of A. We know that the working formula is under root x square plus y square. The value of x is 6 square plus the value of y, it's minus 0.5, right? So that is minus 0.5 square. If you solve it, so it's 36 plus 1 upon 0.5 is 1 upon 2, and I will write 1 upon 2 because I need to show that expression, right? 36 plus the LCM of 1 upon 2, it's 1 upon 4 with the root sign. And you need to multiply 36 by 4, it's 144 plus 1 divided by 4, so the root sign, and that is equals to 145 divided by 4, right? So you need to show that the magnitude of A is equals to 145 divided by 4 with the root sign, and we have just proved that. So I think that is quite enough for today's class. If I summarize today's class, so we will start with the vectors. What are vectors? Then we continue with the column vectors, in which we represent x and y coordinates. How we represent the vectors? By using the line with the arrow on it. Direction is very important. What are equal vectors? Same magnitude, same direction. What are negative vectors? Same magnitude but opposite direction. How you find the magnitude? Simply working formula x square plus y square root, right? So these are all the summary of today's lecture. Inshallah, in next class we are going to continue with vectors from book 4. In the meanwhile, you can explore the book, you can try different questions from the book, so that you have an idea for the next lecture, right? So see you in next class. Take care and Allah Hafiz.